let me also remind you what you may have seen as a model for this ideal transmission line. So normally what we will do is that we will start by essentially chopping this transmission line into very, very small segments with some type of an infinitesimally small delta z. And what I mean by infinitesimally small delta z, essentially it means that this delta z is much, much less than the wavelength. So everything here is obviously with respect to the wavelength. And if that's the case, then by using ideal Maxwell's equations, which I'm not going to discuss here in more detail, you can actually go from this physical structure to this ideal representation. And even though I won't give you the Maxwell's equation solution for that, I can at least let you know some of the physical structures that influence this model. So for example, this R, which is called the resistance per unit length, is related to how much resistance you have on this wire here. So this is measured essentially in ohms per meter or ohms per millimeter, or however you want to define that. This L is similarly related to the inductance per unit length you have in the physical structure and is measured in henries per meter. This C is related to the capacitance per unit length, which, as you can imagine, whenever you bring two wires close to each other, you will always have some type of a capacitance, and this is measured in farads per meter. And finally, this G is related to the conductivity that may exist between these two wires. Now, if you have an air medium or free space between those wires, clearly that G will be 0. But more often than not, we actually have some type of a dielectric in between those wires. For example, in the microstrip line I showed you before, we had a substrate. And that substrate is not ideal. It has a little bit of conductivity, and that is the conductivity that you will actually see here. So in other words, there are two main parts of this model that account for loss. Is this resistive loss, which is related to the conductivity of the wires themselves, and is this conductivity, which is related to the non-ideal conductivity of the dielectric, which ideally should be 0. In other words, that resistance should be infinity, but unfortunately that's not the case, and we have a little bit of loss there. Now, when we actually discuss lossless models, which I will do in a little bit, this guy will become 0, and this guy will become infinity. But in the general case, that's not the case.